Alright, in this second lecture, we'll be dealing with techniques for solving first order differential equations. And the particular technique we'll start with today is separation of variables. But first of all, I'll give you a list of the various techniques that could be employed in solving first order differential equations. Okay, so the first one, like I mentioned earlier, is separation of variables. Separation of variables. The second is homogeneous type. The third is exact form type. The fourth is non-exact form type or integrating factor type. And the fifth, the Bernoulli equation type. So the first one we'll start with is the separation of variables type. Now, for an ODE to qualify to be able to be solved by separation of variables, it must be in this form. So I'll write down the format for an ODE to be qualified for solution using this method. Now, an ODE is qualified if dy over dx equals a function of x times another function of y. Okay, so the fact that g is used there doesn't mean it's not a function, okay? F here stands for function of x, and then g of y stands for what? Function of y. Okay, so now if you can express your first order differential equation this way, then you should be able to do what? Solve it using separation of variables method. So you have dy over g of y being equal to f of x times dx, okay, which will be dy over g of y being equal to dx of f of x. Integrating both sides will give you y. Okay, so if we integrate both sides of this equation, we'll get our y. Okay, so this is just a skeletal view of it. I'm going to be solving a number of questions in this class, and those questions will show you how to get answers to various types of questions that can be solved using separation of variables. Okay, so the first example is this. We are asked to find to solve the differential equation y prime equals 2y plus 4 over x minus 3. Okay, so we have to solve this differential equation. Y prime equals 2y plus 4 over x minus 3. So first of all, this y prime, what does y prime mean? Y prime means change in y with change in x. First order, so it's dy over dx equals 2y plus 4 over x minus 3. Now, based on what I said when I gave the first theoretical example, we have to be able to separate these functions on this side into a function of x times a function of y. Now, can we do that? Let's look at it. We have dy over dx equals, now 2y plus 4 is a function of y because it uses only y to get the answer. So if you want to get 2y plus 4, do you need anything apart from y? No. You need just y to be able to evaluate 2y plus 4. Okay, so 2y plus 4 is our function of y. So our gy here is what? 2y plus 4. Okay. And then x minus 3. In order to get x minus 3, what do you need? You need just x. Okay, so x minus 3 is a function of x. So fx is x minus 3. So this is 2y plus 4 divided by what? X minus 3. Alright, so this way you should be able to bring all the y's together. Remember I said in the last class, the last tutorial, that we should always aspire to bring all the y's together, all the x together, so that we can integrate them with respect to x or y or whatever variable it is. Okay, because you can't integrate x with respect to y or y with respect to x. So in this case now, we're going to take everything y, we're going to bring it to this side, we're going to bring everything x to another side. Okay, so this dy is here already, so we want to bring 2y plus 4 to this side. How do we do that? We can do that by dividing both sides by 2y plus 4. Okay, so we have dy over 2y plus 4 being equal to what? Now, in this case, we have dx, because we cross multiply, so we have dx divided by x minus 3. Okay, so we have both sides looking very much like our general theoretical separation of variable type, which gave us dy over f over gy rather, dy over gy, okay, being equal to dx over fx, dx over fx. Okay, so they look very similar. So that means we can do what? Solve it using separation of variables. So the next step now is to integrate both sides. If you take the integral of both sides. So with this, now when you integrate 1 over something, what does it give you? When you integrate 1 over 2y plus 4, what do you get? You get ln 2y plus 4. Okay. You get 2 ln 2y plus 4, ln 2y plus 4 being equal to what? Ln x minus 3 plus ln c. Now I'm adding plus ln c here because this is the independent variable side, okay? And there's usually a constant here. And that constant, I don't want to put c there because we have everything in ln, okay, natural logarithms. If I put c there, it will make it more difficult. To make it more difficult to obtain our y value, okay? So the easiest thing for us to do is to make it what? Ln c, because both c and ln c, they are constants, okay? So now our aim is still to find y, as always. So we want to isolate y. Now 2 is on this side, we don't want 2 on this side, we want only y on this side. So first of all, we remove 2 from here, by dividing both sides by 2. So we have ln 2y plus 4 equals ln x minus 3 plus ln c divided by 2. Okay, so this is 1 over 2 and this is 1 over 2. So we have ln 2y plus 4 equal to ln x minus 3, okay, half of it, and half of what? Ln c. Okay, now we need y. again reminding us, how do we leave only one on this side? We do e raised to power. We take the exponents of both sides, okay? So that's e raised to power ln 2y plus 4 being equal to e raised to power half ln x minus 3 plus half ln c. So, like I said in the other class, our e will go with the ln. On this side, the same thing will happen here. But then, we need to raise this x minus 3 to power half. Because, like in law of logarithms, from the law of logarithms rather, 1 over a ln p equals ln p raised to power 1 over a. Okay? So, this will be e raised to power ln 2y plus 4 equals e raised to power ln x minus 3 raised to power half plus ln c raised to power half. So this gives us 2y plus 4 equals e raised to power ln x minus 3 raised to power half times c raised to power half. Okay, and that gives us 2y plus 4 equals x minus 3 times c raised to power half. Now, don't forget that we're looking for y. Okay, so our y equals what? X minus 3 times c raised to power half minus 4, all divided by 2. Alright, so with this, we have come to the end of this question. Now, we have a constant here, c. Okay, so this constant c, we will leave it like this for now. But in subsequent times, we will have more than one constant. But for now, we'll leave it as just c. Yeah. So, down to example 2. We have dy dx equals 2xy squared. Okay, so dy dx equals 2xy squared. So we want to express it as dy dx equals f of x times g of y. Okay, so this is dy over dx equals f of x. Now our f of x is what? 2x. Okay, you can't get 2x with any other term from x. You don't need more than x to get it. Okay. And then g of y equals what? Y squared. So that's what? 2x times what? Y squared. So like we always do, we separate the variables, okay? So we take all the x to where the x is, bring all the y's to meet the y. So we have what? dy divided by y squared being equal to dx times 2x. Okay? So we have both sides now separated, the variables on both sides separated. So at this point, we can integrate. We can integrate at this point. So we say that take integral of both sides. Now integral of 1 over y squared is the same thing as what? Y raised to power minus 2 plus 1 over minus 2 plus 1. okay, and that's equal to 2x raised to power 1 plus 1 over 1 plus 1 plus c. Alright, so minus 2 plus 1 gives us minus 1. And we have y raised to power minus 1 over 1 being equal to 2x squared over 2 plus c. Now, this becomes minus y raised to power minus 1 equals x squared plus c. Now, what are we looking for? We're not looking for y raised to power minus 1, we're looking for y. We're looking for y. So that means this is 1 over y, okay? So instead of saying y raised to power minus 1, we'll just say minus 1 over y because x squared plus c. So from here, we can take the reciprocal of both sides. So we can say that 1 over minus 1 over y equals 1 over x squared plus c. So that gives us minus y equals 1 over x squared plus c. Okay, and then y equals minus 1 over x squared plus c. Now, of course, our y is a function of x. So instead of leaving y just as y, we could decide to write y as y of x. Okay, so we could say y of x equals 1 over minus 1 over x squared plus c. So with that, we've come to the end of this lecture. We have dealt with separation of variables with 2 different examples. Thank you.